Hello there and welcome back. In this video we are going to be going over tests of significance, another example problem. In this particular question we are going to be dealing with two-tailed or two-sided tests for the population mean. This is essentially referring to, is the alternative hypothesis equal to 500? For anything that is not a two-tailed or two-sided hypothesis test, the alternative hypothesis is probably going to be greater than the null hypothesis, or it's going to be less than the null hypothesis. When we are dealing with two-tailed or two-sided tests, we're checking if the only thing we are checking is that the alternative hypothesis is not equal to the null one. So we're checking if this one right here is not equal to the 500 above. So the goal for answering this question, because there are multiple ways you could do this, and my particular method for today is going to be dealing with confidence intervals as well. This is actually an easier method, sort of. I prefer it. Now the first thing we want to do is go over the data we have here. This symbol right here is referring to the level of significance. We are using 0.05. You could use anything up to 0.1. The level of significance is just the value you're going to be matching your calculations, whatever you get down here by, to determine if the alternative hypothesis is statistically significant or not. Is it true that it's not equal to 500, or is it not? We're going to be using this level of significance to determine that. This is the null hypothesis. This is the thing that's supposedly true. We're going to be testing this. We're going to be determining if that is the case or not using statistics. This is the alternative hypothesis. This is a thing that needs to be the case if this one is not true. This is sort of what we're going to be testing against this is how we get evidence that this one here is not actually true. This is sigma, the standard deviation of a population. The n here is the sample size, and this is the population mean for the sample. Now we are just dealing with numbers in this question because I got rid of all of the word questions. This was a root beer example of some sort, but I just forgoed all of that data just to get down to the basics, the core question of everything. Now the first thing we're going to want to do is construct a sort of confidence interval. Now how do we do this? Well, the confidence interval in this particular case, since we're going to be using it to work with tests of significance, we're going to be making a confidence interval of, basically it's going to be 100 multiply 1 subtract our level of significance, and this would give us a sort of percentage, the percentage of confidence we want. In this particular question we're using 0.05, so if we actually did that calculation out, we would get 95%, which means we're going to be making a 95% confidence interval for this question. Now I won't be going over how to get the z-score for this in this particular video, but that is covered in the video regarding confidence intervals. Instead, I will be going to the standard normal probability table and grabbing a critical value that's going to be equal, basically it's the end result of the calculation to find the actual z-score for the 95% confidence interval. So this is just a table I'm going to be using to find the critical values that I will have to use for the question. Looking at 95%, the critical value it gives is 1.960. Here are the values for different kinds of percentages if you want to use those, but we're going to be using 1.960. Now we just have to create the confidence interval using the data we have. So if you recall, it's this is the z-score of our confidence interval. It's going to be this, multiply the standard deviation of the population given as being 3, divided by the square root of the sample size, which is given as being 25. So if you just did that calculation out, you would get a 5, and this would give us the margin of error we will be using with the sample mean. The result of this calculation is 1.176. Now it's just a matter of doing the sample mean, which we have is given right here, so 501.1 plus or minus 1.176, the margin of error. If we did the subtraction side, we would get 499.9, comma. Then if we did the addition sort of side of it, we would get 502.3, and this would be our confidence interval, our confidence range for this specific significance level. And that's how you would work with confidence intervals and tests of significance. Now, just to answer this question, we know that the null hypothesis of 500 is within this range right here. And because that's the case, we can say that we do not have enough evidence to suggest that the null hypothesis is wrong. Whenever the null hypothesis here, what is being tested, is within the range of the confidence interval, we always say that we do not have enough evidence against it, and therefore, as a conclusion, we do not have enough evidence to support our alternative hypothesis. And that is the conclusion to this video. If you have any questions, feel free to ask in the comment section below. I will do my best to answer your questions, and I do hope you are having a nice day.